guys. Good guys. Okay, you have two functions, f and g. And one possibility to put together in one different way, not using addition, subtraction, multiplication, and division, is composition. This symbolic way can look like a zero. This or this indicate composition. Composition. And what is the interpretation composition? Well, interpretation is, you have two functions, but the order is extremely important. We have two functions, g and f, but the first function is g. In this case, no, it's the first one, and this is the second, no. And this order is completely different, no. This is the first function because it's the function close to the argument of the domain. This is the second. Entonces, what is the interpretation this? Well, there are many interpretations. One possibility to understand this is, can you evaluate, for example, you evaluate this argument inside the first function, that you evaluate g inside x inside g, and the result of this numerical value, you evaluate in f. Okay, this is the interpretation of f composition g. And this is different. This is you evaluate first in f, and the result you evaluate in g. This is g composition f. One, visual representation of this is you consider it like the function like a black box. So we have function as a black box. In that case, the first function is g. Okay, and any value in the domain x is the input in our change. It's a change group. Now the output of g would be equivalent to the input of f in this case. And finally, we have total output. Okay, this is x. In this case, this is g and x. But now the input is to say this is f evaluating the numerical value g of x. And likewise, in this example, we have first f function. And the output, you have f of x, and this will be now the input in the second function of g. Therefore, this is g evaluate in f of x. To find the expression is relatively easy. More complicated is domain. Okay, to find the domain, there are several procedures. In my opinion, the easy way is domain. The formula is domain of, for example, f composition g in this order is domain of the first function, always. In this case, g, according to this order. Intersection, because it's a set. The operation between the set is union or intersection. The domain of new expression. A new expression is the new expression that you determine when you put together f and g. New expression. It's the one, in my opinion, easy way to understand this. But let's do an example, of course. In general, guys, in general, f composition g no equal g composition f. So it's no commutative. When you interchange the function, you get completely different answer. In some particular example, yes. Maybe yes, but in general, no. Let's see example. So now, what is the typical question? I give you two functions. I give you two functions. Helen Espinosa. Okay, I take attendance. You communicate with the chat. I saw in the laptop. Yeah, I copy in the piece of paper the attendance. Okay. Helen Espinosa. Thank you so much. Well, now, example. Suppose this example, okay, in which is giving f of x is equal x squared plus x plus 1. Semicolon, and g of x is given is 2x plus 3. But what is the typical question? The typical question is determine the expression que represent the composition and the order que is specified in the problem and state its domain. So two questions. Okay, let's do it in this order. F composition G. So I understand que G is the first function. And G is the first function. Completely, go inside the outermost function que es F. So in the expression, you replace no x anymore in F. No. You replace x for 2x plus 3. You have 2x plus 3 square plus 2x plus 3 plus 1. Of course, don't leave it like that because it's totally incomplete. The thing is, you foil here, foil, 2x plus 3 times itself. Let's do it quickly. It's 4x squared plus 6x, because 2 times 3 again is another 6. It's logical que it's repeated because it's twin brother, plus 9. I remove the parentheses here because the coefficient here is 1, que es invisible, entonces 2x plus 3 plus 1. Finally, combine like term. Is 4x squared, and you organize in descending order of the degree. Degree 2, you combine like term, these and these and these is 12, 14, no? 14 plus 9, 12, 13. Okay, this is the expression that represents the composition. Okay, super, this is easy. This is no big deal. Wow, it's super easy. However, the domain, state is domain. The domain of F composition G is the formula, no? Is the domain of the first function, que es G. And G is super important, no? Because you see in the box diagram, see this X value do not satisfy the domain of G, is undefined. So the super important is the first function. But intersection, because somehow F do something, no? In the second stage, but do something. Entonces the domain the new expression. Of new expression. Okay, domain in this case super elementary problem because domain of G, okay, G is this is a linear function. Line, linear. And you know that the domain is all real number, no restriction. Remember, we have restriction only when you have fractions or square roots. Or no, not exactly square roots, you know, any root with the even index, 4 root, 6 root. But okay, the most popular is square root. And the new expression is also polynomial. Therefore, the domain is all real number. So we have no problem, we have no restriction, both set are all real number and the intersection is all real number. Entonces, ¿cuál es the final answer? The final answer is the domain of F composition G is all real number. I promise you see another example more interesting in which no, it's not a real number. But in this case, yes. Any questions so far? Do you follow me?
Yes.
Okay. So let's try in the same example, in the same functions. Let's try to do in different order. And you see it's not equal. Suppose now I need to compute G composition F. Okay, again, we come back at the beginning. Look here. So in this case, the first function is F. Therefore, that function F. Now you substitute here and the x of the second function. So you got 2 parentheses, x squared plus x plus 1, plus 3. Do you understand what you're doing? What are you doing? Do you understand? Yes or no?
Can you repeat it again? I'm sorry.
Okay. In this case, F is the innermost function, this one. Okay? According to this notation, look, F is the innermost. And the innermost substitute in the outermost, que es G. So you replace x for the entire F function, que is x squared plus x plus 1. More clear now?
Yes, thank you.
Now, the recipe is okay. The rest is you distribute the 2x squared plus 2x plus 2 plus 3. Well, that's the only modification, algebraically modification is 2 plus 3 is 5. And the answer is G composition F of x is 2x squared plus 2x plus 5. End story. And this is a new expression. Okay, it's formed by composition of, let me see, yeah, composition F and G, but in this order. Because you know it's completely different to this one. So I prove using one counter example que en general no, the composition is not commutative. So you swap F and G, no, we get different answers. In order to state the domain, it's similar. Because remember the domain is, in this case, the domain of G composition F is equal domain of the first function. Okay, domain of the first function is F, in this case, according to this order, intersection, domain of new expression. New expression. Entonces, in this case, F, domain of F is, look, this is F. This is F. Okay, this is F function. And this is polynomial, or real number, is the domain. And the new expression is another polynomial, or real number. In this example, there are perfect coincidence que the domain is all real number. But not always happen. This depends on the problem, no? Domain G composition F, and this example is all real number. So far it's okay. Do you follow me or not?
Yes.
Okay. When I want to erase the board. I can? May I? Yes or no?
Yes.
Okay. Let's see another example. Example 2. more interesting. Example 2, we have two functions. F k is equal 4 over x minus 1, and g is x over x plus 3. And the same question, I need to find composition in the specific order and state its domain. Suppose let's start in this order, F composition G. Okay. I realize G is the first function. Therefore, this function G substitute here an x value of F. Let's do it. I copy 4 over no x anymore, no. It's x over x plus 3 minus 1. Do you understand what you're doing?
Yeah.
Okay, now leave it like that. No, it's ugly. Let me manipulate a little bit. Okay, 4 stay here. This and this together, I try to condense it in one common denominator, que es x plus 3. It's the least common denominator, no? And we have x minus x plus 3. Do you see that? Exactly the same we are doing in intermediate algebra. Okay, now 4 stay here. And you distribute it here, why not? X minus 3 divided by x plus 3. Wow, look at that. That is cancelled. Positive x and negative x is cancelled. And we have so far 4 divided by minus 3 over x plus 3. This is the answer. No, because this is a complex fraction. So now I propose you, for example, 4 is just 4. It's 4 over 1 times reciprocal this, is x plus 3 divided by negative 3. Okay, so now ready to put together in an elegant way is negative 4 over 3, because 4 multiplication by x plus 3, no? Okay, this is a good expression. Leave it like that. Everyone follow me with the algebra?
Yes.
Okay, now the complicated part. The complicated part is domain. Domain is, you know, the formula say is domain of the first function and domain of the new expression. Okay, domain of F composition G is equal to domain of G, que is the first function in this order, intersection domain of new expression. Okay, let me try to understand this. Domain of G, I come back here to G expression. I copy x over x plus 3. To say, no, wow, we have restriction. It's obvious, right? Because we have denominator. To say, you don't allow the denominator 0 because division by 0 is undefined. So to avoid that situation, you take the expression, the denominator is x plus 3, and never would be 0. What is the restriction? Well, the restriction is x no negative 3. Okay, so you want to represent domain of G alone is x such that x not negative 3. Okay, now domain of the new expression, I go to new expression, que es this. Y ahí sí que es linear function. See, a linear function, so we have no denominator, we have no square root, domain is all real number. And together, es obvio que es all real number, except the only restriction que es -3. So one potential interpretation of this is look, this visual representation of the all real number this is 0 here in the middle. We have 1, 2, and -3 is the restriction of this part. And this represents whole, right? A whole. Let me use in one, well, okay, red color maybe. A whole. And the rest is okay. So you highlight, but you have only one restriction. And the intersection, remember, is a common element. No? All real number represents all the entire line. And the restriction as a whole. So if you want to represent this in the other notation is from -infinity, comma -3, union, -3, comma infinity. In other words, guys, it's all real number except -3. -3 is the only restriction is coming by G, because the new expression have no restriction. Do you understand this very well or no? Confusing or clear?
Clear.
Let's do in the same example, but backward. G first, F first, sorry, and G second. So I want to change the order. And let's see what happens. I don't know. Okay, the same functions, but you combine in different way. You combine like that. G, composition F. Okay, just in case to see much better, I want to copy again F and G. This is the original functions is given. However, I want to combination in different order. That means F is this. You substitute here and here, because in G is the second function, we have 2 places for X, no? So you copy G composition F of X is equal 4 over X minus 1 divided by 4 over X minus 1 plus 3. Do you understand this or no?
Yes.
Okay, likewise. Well, the denominator part, well, the denominator stays the same for a moment. And the denominator, I try to condense in this and this together in only one, using one least common denominator, que is X minus 1. That's a 4 plus 3 times X minus 1. Okay, now you distribute it in order to remove the parentheses. Okay, we have here X minus 1, 4 plus 3X minus 3. Okay. And now I realize, okay, we combine somehow 4 minus 3 is 1. So it's 3X. Plus 1 is positive, no? Because 4 is positive, 3 is negative, subtraction, but you put the sign of the bigger number that is positive, no? X minus 1. Okay, we continue, of course, because we have complex fraction here. And the complex fraction, you are doing exactly the same. It's over 4 over X minus 1. I copy the fraction, and the denominator is exactly the same time, and you flip it up. X minus 1 divided by 3X plus 1. This is cancelled, and it stays 4 over 3X plus 1. Wow. And this is my important and famous expression que represent the composition, the new expression. Super. Okay. Now the complicated part. The complicated part is domain. So the domain of G composition F is exactly the same formula. It's domain of the first function. In this case, F intersection domain of the new expression. Basically, the only thing I need to do is determine the domain of F. Okay, this is F. Look. Okay, I copy here and the domain of this. I copy here and intersection both. Okay, let's do it. Okay, domain of F is obvious. Okay, is you take the expression in the denominator. Okay, it's x minus 1, and you don't allow 0 because division by 0 is illegal. In other words, no 1. So as you express it, the domain is using set builder notation, no? X no 1. Okay, now similar we are doing here. You have the expression gets 4 over 3x plus 1, and you take the expression in the denominator gets 3x plus 1, no 0. And so for x, 3x no negative 1 divided by 3, x no negative 1/3. So the domain for the new expression is x such that x no negative 1/3. And you put together and you intersecting using intersection, no union, intersection. Okay, the representation this domain is or real number. Look, and we have two bad guy. This is 0. We have one whole and 1. And we have another whole and negative 1/3. This is, I suppose that this is negative 1, negative 1/3 look like that. So this whole, this is this. And this is this. This is negative 1/3. Okay. Okay. The rest is okay. The rest of the number is okay. The only bad guy is 1 and negative 1/3. 2 whole. And the rest is okay, because I highlight here. Okay, so what is the domain? What is the answer? What is the domain of G composition F? Well, we have 1, 2, 3 intervals. So the first one is F from negative infinity, comma, negative 1/3, no including 1/3, it's a bad guy. Union, negative 1/3, comma 1, union, 1, comma infinity. And the story. Any question? No question. Dice, sorry, professor, my laptop died. Wow. Christy. This is a disadvantage of the online class. In the online class, you need good computer and good internet connection. So you have no, you cannot take that class. This is the disadvantage. Any question in this problem? Do you understand? I bring another to illustrate much better another idea. Example 3, composition. Example 3, composition. Just in case, this is a recording. I upload in the YouTube. I send the video with the link connection, right? But okay, it's not the same. Okay, you suppose you have now two new functions. Okay, this is by coincidence is the same, but it's not. It's the G is x plus 4 divided by x. And the same problem. We are doing again, repetition, the same. It's composition. Let's do it first of all, f composition G of x. Well, G is the first function, que is this. And substitute where? And the x of the outermost function. And basically, we have 4 divided by x plus 4 over x. This is 4, sorry, minus 1. Do you see that?
Yes.
Okay, now we are doing exactly the same. Condensing one common denominator, que is x. We have x plus 4 minus x. In this case, the situation happened. This x is cancelled out. And we have 4 over 4.
Why do you put minus x like on the next?
Okay.
Like, I'm confused about that.
Okay, don't worry. Okay, you try to condensing this expression and 1, no? So I determine the least common denominator is x because and 1 is just 1, it's 1 over 1. No? So the LCD, least common denominator between x and 1 is always x. I put this x here. You divide x divided by x is 1 times x plus 4 is x plus 4. I'm making sense because it's the same. Same denominator, same numerator. But in this case, no. You divide x divided by 1 is x times 1 is minus x. And this minus is because this is negative. See, this is positive. Well, it's positive. But in this case, no. It's negative. You see or no?
Yes, thank you.
Okay, we come back again to our problem and we almost finish. In this case, well, you have a fractions, complex fraction. So this 4, you consider like a 4 over 1, the top one, and flip that is x over 4. And you see, wow, this 4 is cancelled. And the answer is just x. Wow. The answer is just x. And this is very interesting because when the answer is x, this is the famous identity function. This is the famous identity function. I promise in your moment you see in detail what happened, what's going on when the composition is the identity function. Okay. Now let's move on to domain. Domain of f composition G is domain of the first, que es G, intersection, domain of new expression. Okay, the new expression is this. Okay, by the way, is the identity function. The identity is when the f of x is x. Okay. Entonces, domain of the G, well, it's easier, is you take this expression, you take denominator, no 0. You see? No 0. Let me write to the formal way like that. It's all real number except 0. 0 is a bad guy here because division by 0 is undefined. And the new expression is linear because the identity function is linear. And no division, no square root, entonces it's all real number. or real number, and the intersection, you know, in between all real number and this is all real number except 0. So in conclusion, the domain, not necessary to write the all real number line because you understand very well, I suppose, is all real number except 0. You write like that. And by the way, it's equivalent to say from negative infinity to 0, no including 0 union 0, infinity. This is set builder notation, guy. It's a two different ways to express set builder notation, and this is interval notation. Okay, by the way, interval notation is the most popular I asked you in the test. Okay. Let's do it in opposite direction. Why not? Let's do it in opposite direction. In opposite direction is decomposition f of x. Let's do it in opposite direction. So I want to copy again f and g. No, not necessary copy. I can see. This is f, okay, this. Substitute here and here. So you, in other words, you replace x of g to the whole f. Entonces es 4. Let me try to do. So instead x, no, es 4 over x minus 1 plus 4 divided by 4 over x minus 1. Do you think the thing I am doing or no? Do you understand or no?
Yes.
Again, we have two condensing this in only one. Least common denominator is x minus 1, and we have 4 plus something, 4 times x minus 1 divided by 4 over x minus 1. Okay, let's continue the manipulation algebra. This is, why not remove the parentheses, que es 4 plus 4x minus 4, no? Divided by 4 over x minus 1. So the only thing I did was distribute here. I can see that the 4 is cancelled. Positive 4 and negative 4 is 0. Done. Now, stay 4x over x minus 1 divided by 4 over x minus 1. In this case, we have one more time complex fraction. You copy the first exactly the same time and flip it the second. And this is cancelled one more time, and this is 4 is cancelled again, and one more time we have identity function. Identity function. So the new expression is, in this case, it's a coincidence. In some particular example happen. Not all we have. I want to explain in the next chapter, no, in the chapter 2, okay, when this situation happens, that function, and that function are inverse functions, so undos each other. Like a multiplication, division, addition, subtraction, square root, square, okay, you know, when you put together, undos each other. This is the situation that happens. Undos mean que when you put the composition, you get the identity function. Pero no, don't worry for this now. I want to explain in the chapter 2 in detail this new idea. Let's move on to the domain. Domain of G composition F is equal. Domain of the first function, okay, in this example, according to this order SF, intersection domain of the new expression. Okay, by the way, new expression is identity function, and you know okay, it's all real number. However, domain of f, no. Domain of f is all real number. Look at that. You take again the f expression, you take denominator, no zero, it's no one. Only bad guy that we have in the game is one. So it's x such that x no one. If you want to express it, you say that one of this and this together, you know this part is completely negligible, no? Because the only restriction is this one, and this is all real number. And all real number, you have two sets. One set is all real number, gets the entire number line, and another set is the entire number line except one we have a whole, and the intersection, where the common part, well, the common part is obvious, it's a coincident with this. Okay, so you want to express this in interval notation is from negative infinity, comma 1, union 1, comma infinity. End the story. Any question, guys? Super good or no? Okay.
No questions.
Please. No question? You say no?
No.
Okay, super, good. Let me try to explain another, because maybe in Alex, when you are doing the homework or the test, I don't remember now, we see this problem exactly the same, but in different way. Let me try. No using equations, using set. O sea, suppose que this information is given. Look. So we have a function g, okay, and the domain of g, and this is the range of g, is you have different point, 1, 2, 3, 4, 5 point, 3, 4, 5, and this is 1, this is 2, this is 3, this is 5, this is 6. Associate somehow with the 1, 2, 3, 4 point, 1, 2, 3, 4 point, que es 1, es 2, es 3, and es 9. Okay. Entonces the association is this. 1 is associated with the 1. You know the arrow indicate the direction, no? Because this is domain. Always the association is from domain to range. And 2 is associated with this. Again, no problem because many to 1 is okay, no? No violation of the function idea. 3 and 2. 5 and 9. And 6 and 3. That's the order. Okay, this is the function g. This is the function g. G of x. It's defined not by equations, it's defined by this arrow diagram. And the function f is defined similar. This is domain of f. This is the range of f. You have 1, 2, 3, 4, and 5. This is 2, 3, 2, 3, 4, 7. No, more. Wait. 7, 8, 8, and 9. Wow. And on the other hand, we have 2 and 3 and 6. Okay, arbitrary. Depende del problem, ¿no? O sea, the association is 2 and 2. Let me use another color. Blue is okay. 2 and 2. 3 and 2 again. 4 and 6. 7 and 6. 8 and 3 and 9 and 2. Okay, no problem, because it's a typical example. This is the function f, k is many to 1. No violation of the definition of the function. Now, where's the problem? The problem is I need to find f composition G. And why not? State is domain. State is domain. Okay, just remember, the idea is you have one function que es f. Que es G, sorry. G is the first, the innermost. And the second is f. So basically, we need to do something in order to put in this order. When you put in this order, the starting set is this. And this is associated with the one guy here. But now the problem is to find here, look, to find here the connection in between two, okay, the continuation of f. So basically, I need to compute or determine the intersection, the range of G, intersection domain of f. So what are the common guys? What's the common element? Well, okay, the common element, let me see, I saw two is common, look. One more is common, 3 is common, yes. And one more is common, 9 is common. And the rest, no. So the rest do not participate in this game of the combination of the composition. So as you are doing, for example, the set que is formed by the intersection range of G and domain of F is only 3 elements, que is 2, 3, and 9. Okay, so let me try to connect in the rest. So this and this together was this. So I copy this. Again, copy this. Yeah, I copy this. The guy gets not necessary. I don't copy. I copy only 3, 5, and 6. Because 1 and 2, no. Because 1 and 2 was associated with the 1, and 1 disappeared in this set. So the connection is 3 connecting by 2. 5 connecting by 9, yes. And 6 connecting with 3. And the other set, well. I suppose that the only guy can stay alive is 2. Because, you know, 4, 7, and 8 is connecting by 3 and 6. But the only que connecting by 2 is 2, 3, and 9. Okay, entonces the second stage in this change is this. Connecting with the 2, 3 connecting with the 2, and 9 connecting with the 2. And 3, 6 is not right here because it's completely useless. The reason is that in this set disappear 4, 7, and 8 is the connection with the 3 and 6. In conclusion, if you want to determine domain and range, well, not necessary to write this intermediate stage. Not necessary to write this intermediate stage. This is the domain. Domain of F composition G, and this is the range of F composition G. In other words, in one easy word, you copy only 2 sets, this and this. Okay, I copy 3, 5, 6. And you copy here just 2. And the connection is directly not directly using intermediate path with the 2. Here, intermediate path with the 9, but 9 disappear. No? Not disappear, stay here, but one symbolic way to condensing this information in 2 set only is this. So what is the super fantastic conclusion? Well, the super fantastic conclusion is domain of the composition is the set 3, 5, 6 in the story. And the range of F composition G is just 2, only one number. All right, now I want to, using this information, to compute, for example, at the beginning, for example, I need to find F composition G, evaluating 3. No, en 3 no. Bueno, en 3 yes, pero no, okay. Okay. F composition G and 1. So I'm using the same element here, 1, 2, 3, 5, because the hypothetical value at the beginning, no? F composition G and 2. F composition G and 3. F composition G evaluate in 5. F composition G evaluate in 6. Okay, let me start for the, in the last sketch, I can see clear. F composition G, because actually this is F composition G, and 3 is 2. Look, 3 associated with the 2, 5 associated with the 2, and 6 associated with the 2, 2, 2. And what about 1, 2? At the beginning, we have 1 and 2. Look here. 1 and 2 lost inside this. That's the reason that this is undefined. In the story, undefined, undefined. Do you understand a little bit, or it's confusing? I suppose in the test I don't put something like that. Pero maybe in Alex, in the homework, maybe yes. But it's no big deal. It's just you put together, you try to find the intersection between the range of the first function and the domain for the second. Entonces no common guy disappears. Any question? Clear, confusing? Super confusing, eh?
Here.
No bad. It's a little bit clear. Okay. Well, I have before I start review, I have 2 topics I want to discuss, but it's super easy, super easy. Look, the first topic I want to discuss with you is the symmetry. This is extremely important. Symmetry. Symmetry of functions. Entonces we are testing the symmetry because it's important when you are doing the graph of the function. So you prove somehow que symmetry fantastic. Because okay, let me see. Okay, but how are you testing that? The test is easy. You have a function and you replace x for negative x. That's the only thing you should do. When you are doing this, several possibilities happen. The first possibility is that nothing happens, that the function stays the same. What means that? That the function is even. If the function is even, is symmetric with respect to the y-axis. So symmetric with respect y-axis. Okay? Maybe it's important. Yes, it's extremely important. Why is it extremely important? Because even function. Because the graph look like that. Look. Suppose the graph. Suppose the graph like that. This is X. But when you test in the symmetry, the graph look like that. Let me try to do my best, guy. Completely symmetric with respect to X. Because the action was, you take one arbitrary X and you replace this to the negative X. It's the same distance, but in the opposite direction. And you get exactly the same Y value, que es f of X. Okay, entonces now, what is, okay, I understand, but I don't understand the application. The application is clear. You are doing the graph, and you prove somehow que it's even. Si es even, entonces you dedicate to plugging in points in the positive part. Because I know que the point in the negative part is completely symmetric, it's the same value. So you save time. You save time. Another possibility of the symmetry is when you replace X for negative X. This is the test, guy. Test of symmetry. Replace X for negative X. You get completely opposite signs. So this negative I introduce artificially inside the parenthesis. Magically happen que is outside the parenthesis now. When this function satisfies this condition, it's because it's odd function. Entonces, what is the characteristic of the odd function? I symmetric, pero another kind. Symmetric with respect the origin. Okay, interpretation, graphic interpretation this. Well. Suppose the function like that, similar. So you prove que es odd, entonces es in the opposite direction. Because when you pick one arbitrary value of the X, you get one arbitrary value of the Y, or f of X, it's the same. You know, Y and f of X is the same, function notation. However, when you pick negative value, okay, suppose that this is 3, this is negative 3, you get exactly the same value, but opposite sign, minus Y. This is the reason. So this is typical symmetric with respect to the origin. Why with respect to the origin? Because you put in the origin, you see that this segment and this segment is the same. Otherwise, when not satisfied, when this is no even nor odd is neither. Entonces, unfortunately, si es neither, we have no symmetry. And you need to dedicate more time, analyze the negative part and the positive part because it's completely different. Do you understand the idea?
Yeah.
Let's see example now. Let's see example. I promise in the review packet, we go over to everything at the beginning. Suppose this example. Example 1, suppose the function is given is x squared plus x to the 4th power plus absolute value x. And you need to test in symmetry in this function. Okay, let's do it. You replace x for negative x squared plus negative x to the 4th power plus absolute value negative x, no? Entonces you know, okay, one interpretation of this, you suppose you have negative x to the 2nd power. This is equivalent to say negative 1 times x, no? Square. And this is negative 1 square times x squared. And negative 1 squared, positive 1, so xs squared. So you know by memory, when the exponent is even, and this is no coincident, this name and this name. So even exponent is even function. So it's x squared positive, exactly the same happen in the 4th power. Exactly the same happen in absolute value because you know very well the absolute value any negative number is equal to positive number. So it's absolute value x. And we compare this expression, new expression after the transformation, que by the way is reflection, with respect the y-axis and the original. They are identical, they are twin brother. Therefore, definitely, this function in the example 1 is even function. Good. One more example. Example 2. Suppose the function g is equal x over x squared plus 4. I want to test in symmetry. Okay, let's do it. You replace x for negative x. Entonces es negative x divided by negative x squared plus 4. And the top stay negative x. And the bottom no, because it's even, right? It's even exponent, entonces positive. In order to understand much better this solution, I recommend you put this negative sign in the front. It's equivalent, no? You know that when the fraction is negative, you put a negative in the numerator, you put the negative in the denominator, but more elegant, you put the negative in the front. It's the same, right? And it's the crucial moment in which you compare this expression and this expression. It's the same, no? No, it's not the same. It's not even, but it's odd. Remember the definition of the odd. Odd is a function that when you replace x for negative x, magically happen. Okay, this negative inside the parenthesis now is equivalent to one negative outside the parenthesis. It's exactly the same case. It's odd function. You follow me?
Yes.
Example 3. Suppose the function h of x, que es x squared minus 3x plus 5. I want to test in symmetry. Again, I replace x by negative x. This is negative x squared minus 3 times negative x plus 5. Okay, I know that when the exponent is even, it's positive. But negative, double negative, positive again. Nice, plus 5. And we compare this guy and this guy. Is identical? No. This is not even. It's completely opposite signs like this? No. The conclusion is neither. Very well, guy, or no? You follow me?
Good.
Nice. I like this class. You have a few questions, and the question you are doing is a smart question. Okay. Now, the last topic before start review is easy, but it's a little bit confusing. It's easy but confusing. When you get the idea, you have no problem. Is determine, look in the graph. See, one function is increasing. So one function is increasing, decreasing, or constant. Okay, let me explain the definition of this. Okay, you have the graph. However, you pick arbitrary x value, two value. Always the convention is x2 greater than x1. See, this situation imply that f and 2 is greater than f and 1, the function is increasing. Let me explain. One picture is much better than 1,000 words. X value, y value. Suppose the function like that. You pick 2 points. And one specific interval you want to analyze. This is x2, get a bigger, look. This is s1, get a smaller. However, this is f evaluate in x1 and f evaluate in x2. Okay, entonces now you see clear que f evaluate in 2, que by the way is y2, it is a y1, is bigger than y1, entonces the function increasing because it's going up. So one super easy elementary way to understand this, you believe that the curve look like a roller coaster, and the car of the roller coaster travel always from left to right. See the y, see the height is going up, is increasing. So this is typical increase definition. Number 2, the same condition, you pick x2 bigger than x1. However, something weird happened. fx2 is smaller than fx1. This is decreasing. Decreasing. Let me see one picture for the decreasing. Okay, suppose a function like that. Decreasing. You pick 2 values of the x. x1, x2. However, the y value of this is y1, or f of x, evaluate 1 in x1 and y2. And you see that y2 is smaller than y1, this is decreasing function. And the other case is constant. Constant is when the height stays the same. So you pick 2 values again, x2 greater than x1. This is the condition always. However, happen that it's the same value, equal. Entonces, en this specific interval, this is x1, this is x2, this is a constant, and constant look like the horizontal line, and the y is the same. Look. Is y2 equal y1, it's the same value. Therefore, it's constant. This is easy to understand. Everyone understands very well this. What is the confusing part? The confusing part is that the answer that they want, that you offer in the test, is an interval notation, is only the consideration que es the domain, and the domain is x. And so now, let me try to explain one elementary example. Suppose que is given one function like that, but let me use the rule. Suppose now y-axis 90 degrees. Okay. Okay. There you go. X and y. Suppose the function look like that. Oh no. Let me change a little bit. Y. Suppose here, and here. Maybe continue forever, and maybe continue forever here. Entonces, of course, given that point, maybe this point is 2. Maybe this point is, I don't know, 3, 4, 5, 6, 7. That's something like that. Entonces, to confuse you, I give you the y value. This y value maybe is 10. This y value is maybe 5. I say to confuse you because I never using this number. So the y value no. Entonces, the question say, write the interval in which the function is increasing, decreasing, or constant. And express the answer in interval notation. No? And default is clear que the value that we are using in the interval is always the x value, please. Okay, so you put here increasing equal decreasing equal constant equal. Entonces es obvio, remember, from left to right, in the direction of the arrow of the x-axis, you put the roller coaster car travel for the curve. Entonces, what is the interval gets increasing? Well, I saw gets from negative infinity because this arrow indicates, or the interpretation of this arrow is that this curve continues forever in the same direction. So it doesn't change for the middle, no, stay the same. So this is a negative infinity. Okay, I don't see, but I suppose. 2. Here. Because the 2 change to constant, no? This is a constant. And this is also constant, and this is decreasing. And what about the behavior of these 2? 2 is neither nor increasing nor decreasing because it's the corner, right? And in this corner we have no behavior. So you do not include 2 inside the increasing interval. Okay? And decreasing is from 5 to 7. No include the endpoint. Never, because there's the connection in between 2 behavior different. So it's no undefined. And constant is in between 2 and 5. But you have 2 pieces, no? Those union 7 to infinity. End the story. So this interval is constant. This interval is increasing. It's continue forever in that direction. And this interval is decreasing maybe. Yeah, for sure. And never you include the endpoint because of the transition point. Okay. This point. Now here in calculus, receiving a specific name. It's like a local max. And this is local mean, maybe. But I don't care that part here now. Do you understand very well? This is super easy. What is the confusing part? Okay, the students try to mix the x and y, supposed to confuse you in the test. I give you one example like that. Look. Entonces I suppose que esa parábola like that. Boom. Entonces to confuse you, I give the point. This point is the point 2,0. This point is the point negative 2,0. And this point is the point, I don't know, 0,7. This is x, and this is y. Entonces the question is the same, no? Increasing, decreasing, and constant interval. Well, entonces now again the roller coaster, no? Car travel from left to right, so from negative infinity to positive infinity, no? And this, okay, don't be scared or don't care this arrow, because this arrow, the only thing indicates is that this continue forever in the same curve, but no indicate direction of the roller coaster. No, the roller coaster always travel from left to right, left, right, always travel in that direction. Entonces es obvio que the roller coaster car is going up from negative infinity to 0. And this 7 no participate in the interval because the interval is always expressed using x value, never y value. To confuse you, I put 7, 0, another stupid number, right? And decreasing is obvious that decreasing is in that part when the roller coaster is going down. So basically, In 0, we have a local max. But I don't care that part. This is the calculus part. Local max. Now, local max by definition is the point in which change the behavior. The function is increasing and stop increasing, not increasing anymore, and it's going down, decreasing. And this is local max by definition. And local mean is the opposite idea, decreasing and increasing, local mean. But it's not important. This is calculus idea. So now decreasing is from 0 again to infinity. Of course, 0 is not including the interval because 0 is a local max. And what about constant? Never. And you can indicate no. Super good or no? Any question? Any question?
All good. All good.
All good. And so we start review, guys. Okay, don't worry, be happy, relax. We have time to do good, everything. Let me try to put the first page PDF. Okay, let me try to find. Wait. No. MAC1106. I suppose it's this page. Let me see if it's this or not. There you go. It is. Let me enlarge the side of the page. Guy, I sent to you today this, no? And this is a review at the beginning, okay? In the first lecture of this semester. Okay, question 1. Square root negative 16 times square root negative 25. Immediately you see negative number inside the square root. I know very well, okay, this is imaginary. You compute the square root positive 16 get 4 and you put I. The answer for I times 5i. This is 20 I squared, but I need to see, don't leave it like that, never. Because I know okay, I squared is negative 1. The answer is negative 20. End the story. This is my answer. Any question, guy?
No.
Question 2. Square root negative 81 times square root negative 9. Exactly the same. Square root 81 is 9. Put a 9i. Times square root 9 is 3i. See, the number inside the radical is positive. No I. It's only when there is a negative number inside the square root, no? Entonces, 27 I squared, and immediately you put negative 27. End story. Any questions so far? Easy, eh? Number 3 question. Okay. Number 3 question is super easy. However, some students make a mistake. It's addition and subtraction, complex number. And some students, I don't know why, do FOIL. FOIL is multiplication. No, it's addition and subtraction. So addition and subtraction is easier. You have 3 complex numbers, 5 plus 8i minus parentheses 1 plus 8i plus parentheses 2 plus 10i. So the only thing you should do is remove the parentheses. So 5 plus 8i minus 1 minus 8i, because this negative affects everything inside the second complex number, no? And this stays the same. And the rest is combined, real, imaginary, real. Entonces 5 minus 1 is 4 plus 2 is 6. Now imaginary. Well, positive 8 I and negative AI is cancelled. Wow. Stay alive only 10I plus 10I. End story. Final answer. Any question? No problema.
No.
No. Okay. Dice, so far so good. Maricelis Benitez. Okay, Mariceli, good. Thank you for your... Okay, you coming. Let me erase that part. May I, guys?
Yes.
Yes. Okay, let's move on to number 4 question. Number 4, yes, it's multiplication. Number 4 is multiplication. Multiply 3 minus 4i times 2 plus 5i. It's obvious, in this case, you can FOIL. 3 times 2 is 6. 3 times 5i, 59. This is minus ai. And this is minus again because of negative and positive. There is 20i squared. One more time, we have a square. Yeah, I know that I squared is negative 1. Entonces double negative, the negative of the I inside here, and another negative become positive. 6 plus 15i minus 8i plus 20. We combine real, 27. And we combine imaginary, 15 positive, 8 negative, 7 positive. Final answer. Easy, eh? And division, no. Only multiplication. Division is similar. It's the same, similar procedure. Now let's move on to the quadratic equation. Quadratic equation using completed square. Quadratic equation using quadratic formula. Radical equation with the absolute value, and inequality with the absolute value. Let's do it. Let's do number 5. Number 5 is too easy. Number 5 is a typical quadratic equation. Can we solving by square root method? Because somebody, not me, do the factorization. So I take advantage of this. You apply square root both sides. And so you get square root and square powers cancel out each other. And we have plus or minus. This is the only thing you have to remember. Square root contains 2 values. The positive is the main, the most important, but the negative is also solution. Therefore, x, is my goal, is minus a plus or minus radical 17. Leave it like that. Actually, we have 2 solutions, no? It's minus a plus 17, radical 17, and minus a minus radical 17. Use, if you want, you copy separately and separate by comma. Oh, I understand very well. So you're using the double sign plus and minus. It's the same. All like that. Separate by comma, no? So you put listing, open this brace, comma. Any question? No?
In the test, we can make
the
plus and minus. We could do the like we can
Yeah, I accept both ways. The way you prefer. Yes. Okay. What do you prefer? Plus or minus?
Yes.
Me too. Okay, let's move on to number 6 question. Number 6 question is x squared plus x plus 3 equals 0. And they want to using the quadratic formula. Okay, super, nice. This equation is already expressed in standard because right hand side is 0 and organized in descending order to the degree to 1, 0. Identification perfect, who is ABC. A is 1, B is 1, C is 3. And now plugging it into the quadratic formula, que is minus B plus or minus square root B squared minus 4AC divided by 2A. This is my famous formula that I need to memorize. Or no memorize, you copy. Because the test is at home. So you see your notebook, no? I'm plugging in. It's minus 1 because B is 1 plus or minus square root 1 squared minus 4 times A is 1, C is 3 divided by 2 times 1. Okay, so we focus in the operation inside the radical because it's the first one that you should do according to the order of operations. So this guy, I focus in this. And 1 squared is 1. Minus 12. 4 times 1 is 4 times 3 is 12. It's negative 11. And immediately I compute the square root this. Well, 11 is prime number. We got no simplification more, but it's negative. So it's I square root 11. Something like that. So far, we have negative 1 plus or minus I radical 11 divided by 2. So immediately you see the solution is a complex solution. So say you need to express a complex number in a standard form. The standard form is you separate the real part and the imaginary part. Actually, the final beautiful answer is negative 1/2 plus or minus I radical 11 over 2. Okay? You leave it like that, it's okay. Well, no, it's okay, but it's not elegant. The elegant way is this. Okay? Any question? Well, I propose you. Okay, keep going. Any question, guys? No problem. No? No. Okay, let's do it now. Next, get number 7. No? And number 7, we have, again, the quadratic equation, but in this case, the test say, wow, I need by completed square, no quadratic formula. So you are doing number 7 question using quadratic formula similar to the question 6, you have no credit because it's clear the message here, solved by completed square. So you need to practice a little bit, completed square. 7 is x squared plus 4x plus 29 equals 0. Okay, the equation is already expressed also in standard, nice. However, 29 is completely useless. No, I don't like this. You organize in that way. X squared plus 4x plus a box equal, I move 29 to the right hand side plus the box. Inside the box, I put the magic number that completed square. And the formula is b over 2 squared. Okay, b is 4 in our specific example. This is 4 divided by 2 squared. 4 divided by 2 is 2, 2 squared is 4. It's a coincidence that it's 4. Not always happen, but in this case happen. So when you complete the square, magically happen that this new trinomial is perfect square. And the factorization is x plus 2 squared. Wow, what comes from these two? One of these two is square root 4, look. And this x is square root x squared. And the middle term is only 2 times the multiplication both. So 2 times x is 2x times extra 2, 4x. This is classical of the perfect square trinomial. Okay. Entonces in the right hand side we have minus 25, no? Because negative 29 plus 4 is 25. Okay. I like that. Now, ready to apply square root method now. You apply square root both sides. Okay, this is x plus 2. And this is plus and minus 5i. Because it's an imaginary number, no? 25 is negative, inside the radical is I, and the square root of 25 is 5. Therefore, the final answer is x equals minus 2. I move 2 to the right hand side, plus or minus 5. That is my solution. Actually, we have two solutions, no? Normally, when the solution is complex, it's coming by pair of conjugate. Remember, conjugate is, suppose you're listing the solution like that. Solution set is negative 2 plus 5i is one solution, and negative 2 minus 5i is another solution. And they are conjugate because the definition for the conjugate is can the imaginary part have opposite sign. I don't care the real part. So the conjugate minus 2 plus 5i conjugate. This is a symbolic way to indicate conjugate is minus 2 minus 5i. And always coming by couple of conjugate, the solution. Any question? No? Okay, we're doing one more. I stop because I want to dedicate the rest of the review for the next week, okay? One more, that's it. It's okay?
Yes.
Do number 8 and stop. Okay. There you go. Boom. Okay, number 8 is a classical example of the equation that, by the way, is a little bit wrong. Okay, it's x squared minus 8x x to the 4th power, sorry. It's the same variable, no x así. This is crazy. O es z o es x. Let me select z first. So in the test, I can see que the example considers z. To denote que es a new kind of equation. This equation is quadratic formula. Okay, this equation actually is a polynomial equation. And by the way, the degree of this equation is 4 degree, because degree by definition is the higher exponent, 4. Now, when this situation have a polynomial equation, degree 4, when you finish the problem, we expect 4 solutions. Okay? And the super fantastic way for solving, well, you can do it any way. For example, one student prefer factorization directly. And the factorization is c squared, because this is a square root of this. And the combination 12 and 8 is, I suppose, 6 and 2, no? Because 6 times 2 is 12, and somehow 6 plus 2 is 8, and negative of. Okay, now you separate in two equations. The first equation is c squared minus 6 equals 0, or c squared minus 2 equals 0. Now you have in that moment two new quadratic equations, and this is super easy solving by square root. So square root is useful when the b is 0. In this case, b is species, so the term that contains c is missing. Entonces C squared is equal to 6. 6 squared is equal to, apply square root both sides. C is equal plus or minus radical 6. And C is equal plus or minus radical 2. Okay, entonces the solution set in this example is plus or minus radical 6, comma, plus or minus radical 2. You realize that we have 4 solutions, no? So you list them separately, a radical 6, negative radical 6, radical 2, and negative radical 2. 4 solutions, and this is exactly what we expect because the degree of the polynomial equation is 4. Another possibility to do this problem is using U substitution. The student can like that way, perfect, no problem. I understand 100%. However, another student say, no, professor, you explain that this equation, we are doing U substitution. What is U substitution? U substitution is declare new variable U, auxiliary, okay, C squared. You always taking the smallest point. Why? Because when you replace in the equation U, the auxiliary new variable, this is minus AU, and this is U squared. Entonces, this new equation actually is quadratic equation. And the quadratic equation, well, by quadratic formula or factorization, in this case, the same factorization, no? U, pero U, no C squared, it's the same. 6 and 2, negative, negative. We have the solution that is U minus 6 equal to 0, U minus 2 equal to 0, U is equal to 6, and U is equal to 2. Now, but who is U? So U is C squared. And we come back again to this moment. This moment is this moment. You apply square root. C is plus or minus 6, and C is plus or minus 2. What is the advantage and disadvantage? This is easy in my opinion. However, this is more general. In another example, it's more complicated, more general using U substitution. But either way. What honestly, what way you prefer, the first one or the second one?
Probably the first one.
The first one, okay.
The
But in this
first.
case, but in this case it's easy. But suppose que I put, for example, fraction exponent. Entonces it's more complicated doing. Well, no, it's possible. Either way, like I said, either way. Okay, guys. Entonces you have no question. Okay. I suppose in my mind, okay, you are working in the homework 1, 2, and 3. Yesterday, I have tutoring service, and only one student is coming. Okay? Entonces, bueno, no, yo no. Si you don't like with me, no problem, I understand. Pero it's important que this homework and this test online is due February 1st. You are a student, I understand that you have some question because you don't understand something or technical issue. And the Alex sometimes is a little bit complicated, no, to write, to typing the solution. Okay, so now you know que every Wednesday from 11 a.m. to 4 p.m. I am available in the lab. However, another tutor, que Jose Alegre, is available the rest of the time. And you have preference, no appointment. Once you make appointment, much better. No appointment. You say I am in the Professor Taboada class, MAC1106, and you have priority. Of course, the Jose Alegre cannot interrupt another student, no? But when they finish, you are the next in the list. Okay? Okay.
Professor.
Maricelis Benitez, thank you. Okay.
Good morning.
Good morning.
For Jose Alegre, is it in the campus or is it online?
No, online.
Okay.
Online. You know how you get the inside, right?
No.
No, why not? Let's explain here. Okay, in the home page. Okay. Explanation again.
Thank you.
let me open. So let me stop sharing. Stop sharing. You see my face now? Oh, no. Wait.
Yes.
Let me stop recording. Stop recording, not recording that part.